Hi everybody. Please grab your Unit 5 notes and you should be on the lesson 5.4. So this is really a continuation of what you guys did yesterday, especially that very last story problem where we had to multiply every term in one equation by -1. So yesterday most of the problems were set up for you so you could just add right away and a variable would cancel. This time one of the variables will not automatically cancel out. So we are going to have to multiply every term in one, or in sometimes both equations, by a number so that we can make one of the variables cancel out. And really what we're trying to do is get one of the variables to have the same number but opposite sign in front. So we want something like 4x and -4x, because when you add those together, we get 0. So check out your first example. When you first look at this, let's check and see if something's going to cancel out. So right here, I see 2x and 3x. If I add these two up, that'll be 5x. That doesn't cancel out. Right here, I see -1y. Remember, if there is not a number there, think of that as a 1. And that's not gonna, we have -1y and +4y. Those are not gonna cancel out. So we need to multiply one of these equations by something to try to make one of the variables cancel out. I like to look for a variable that has a 1 or a -1 in front of it. I know this second one down here is +4. That means I would really like this one to be -4 to make those cancel out. So what I'm going to do, I'm going to multiply this whole top equation by 4. So the key part here, every single term has to get multiplied by 4. So I'm going to do 4 times 2x, and I'll get 8x. 4 times -1y is -4y. And then don't forget about this last number. 4 times 6 is 24. The other equation, I'm just going to recopy right here. I'm not changing anything. 3x plus 4y equals -2. And if we did this correctly, then we should be able to change this to an addition problem, and one of the variables will cancel out. So now, look at the x's. We have 8x plus 3x. That gives us 11x. Now we have -4y plus 4y. So the same number, opposite sign, that's 0. And that was the whole point of us multiplying. So we got the y's to cancel out. And then on the other side, we have +24 plus -2. That's going to be 22. So the way I can tell we did this correctly is because I only have one variable left. In this case, it happens to be x. So to get x by itself, I can divide both sides by 11. We'll get x equals 2. Big thing to remember, you are not done. Remember, your answer needs to be an ordered pair. So that means we still need to plug x equals 2 back in to get y. So now we can pick either equation. There is one that I think is better. I'm going to pick this bottom equation right here, mainly because I don't want to deal with that -y. If you do it correctly, though, it should not matter. Either equation would work. I'm going to pick that bottom one. So 3, instead of x, I'm plugging in 2, and then plus 4y equals -2. 3 times 2, I'll get 6. And then I'm trying to get y by itself, which means I need to move this +6 by subtracting 6 from both sides. Be careful right here, these are both negative. So really I can think about adding them up. 2 plus 6 is 8, and because they're both negative, I'm going to keep the negative sign. Now I need to divide both sides by 4, and I'll get y equals -2. When you write your answer, remember it does need to be an ordered pair. So we figured out these two lines would actually cross at the point 2, -2, and that would be your solution. Example 2 is really similar. So remember, check to see if anything's going to cancel out. Here I see positive 2x, and that's positive 1x. Remember, put a 1 there if there's not a number in front. And then over here I see positive 3y and positive 2y. That's not going to cancel out. So when you have to multiply, I always look for the variable that has a 1 or a -1 in front of it. So I'm going to cancel out the x's. This equation right here has positive 2x, which means I really would like this one to be negative 2x to cancel those out. To make that negative 2x, that means I have to multiply this whole bottom equation by -2. So remember, every single term has to get multiplied. So -2 times x is -2x. -2 times 2y is -4y. And then -2 times positive 5 is -10. One of the most common mistakes is not remembering to multiply every single term, especially this very last one. The top equation I didn't do anything to, but I'm going to rewrite it just so everything is lined up. 2x plus 3y equals 6. And now I'm going to think about this as an addition problem. So positive 2x plus -2x, that's 0. So those guys cancel out. Right here we have positive 3y and -4y. If you need to, take a second and draw that number line. So I'm starting at positive 3. I'm adding -4, so I need to go 4 to the left. 1, 2, 3, 4. So really, this is 3, this is 2, this is 1, here's 0. So we end up at -1. So -1y equals, same thing right here. I'm going to think about drawing that number line. This time I'm starting at positive 6, and I need to count 10 to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's figure out where 0 is. 5, 4, 3, 2, 1. Here's 0, and I actually end up at -4. These are good things to practice without your calculator. Now I need to get y by itself. Divide both sides by -1. Negative divided by negative. We know y is positive 4. Don't forget though, that's only half. So now take a second, plug y back in, and solve for x. Doesn't matter which equation. I'm going to pick the bottom one because I see some smaller numbers in there. That's what it looks like when you first plug it in. We'll get x plus 8 equals 5. Subtract 8 from each side. If you need to, draw that number line. In this case, we'll get x equals -3. And then remember your answer written as an ordered pair. -3, 4. Alright, check out example 3. So the big thing I notice in the first two examples, we had something that had a 1 or a -1 in front of one of the variables. This time we don't have that. So this one might be a little bit trickier. I'm going to look at the x's first. The smaller number is 2. There's nothing I can multiply 2 by very easily to get 3. Now I'm going to look at the y's. I'm going to look at the smaller This is 2 right here. There's nothing I can easily multiply 2 by to get 5. So this is one where I'm going to have to multiply both equations by a number. One thing I do notice, I notice the y's right here. I already have one that's negative and one that's positive. So I'm going to choose to cancel out the y's. What I can do here, I know 5 and 2 both go into 10. So I'm going to try to make this top one negative 10y and the bottom one positive 10y. So to do that, this top equation, I need to multiply everything by positive 2. And I'm going to rewrite it off to the side here. So 2 times 2x is 4x. 2 times negative 5y is negative 10y. 2 times 8 is 16. Now on the bottom, so I got negative 10y right here. I really want this to be positive 10y, which means I need to multiply by positive 5. And remember, you have to multiply every single term. So 5 times 3x is 15x. 5 times 2y is 10y. And then don't forget 5 times that 31. We'll get 155. If we did this correctly, then we should get one of these variables to cancel out. So let's think about this as an addition problem. And right here I notice we did this correctly because I have a negative 10y and positive 10y. When I add those guys up, that's going to equal 0. So we just got rid of one of the variables. Now let's do 4x plus 15x, that's 19x. We already know the y's cancel out. On the other side, we'll get 171. We're trying to get x by itself. Divide both sides by 19. And in this case, x is going to equal 9. Remember, you're not done. Take that x equals 9, plug it back into either equation. I'm going to choose that bottom equation mainly because I don't see any negative signs in here. But it does not matter, either equation would work. So this is what it looks like. Subtract 27 from each side. We'll get 2y equals 4. Divide both sides by 2. That means y equals 2. So our answer, we got x equals 9, y equals 2. Alright, we're going to pause here for a second. I want you guys to check out example 4 and try it on your own. Talk to your partner. See if you can help each other out. And we'll start the video back up in just a couple of minutes. Alright, on example 4, I notice this is positive 3x. We have 1x. That's not going to cancel out. If I look at the y's, we have 1y and 5y, and those are not going to cancel out. So you do have a 1 in front of the x here, and you do have a 1 in front of the y. So you could cancel out either variable pretty easily. It doesn't matter which one you cancel out, you'll get the same answer in the end. I'm going to choose to cancel out the x's, and that's just because 3 is a slightly smaller number than 5. So if this top number is positive 3, that means I want to make this number negative 3, which means I have to multiply every single term by negative 3. And I'm going to write the result right next to it. I'll get negative 3x minus 15y equals negative 102. The top equation we didn't have to do anything to. I'm just going to recopy it. And then, remember, we're going to change this to an addition problem. I canceled out the x's. Positive 3x, negative 3x is 0. When I add up the y's here, I'm going to get negative 14y equals negative 98. Divide both sides by negative 14. And we'll get y equals positive 7. So even if you canceled out the other variable, you still should have gotten y equals 7. And then take that value, plug it into either equation. I'm going to pick the top one. So I get 3x plus 7 equals 4. And I'll get x equals negative 1. If you chose to cancel out the y values, you would have gotten that negative 1 first. You would have figured out x first, and then plugged in that negative 1 to find y. But no matter what, if you did the work correctly, everyone should have gotten that same point. Alright, the last one you guys have is a story problem. This is very similar to the tulip time story problem we did yesterday with the deep fried Oreos and the elephant ears. So I would like you to take a minute, read the story problem, try to set up the equations, work with your partner, and then in just a second I'll show you the equations and we'll finish solving. Just so we're all using the same variables, I'm going to call popcorn, the cost of a popcorn I should say. I'm going to call that letter C for corn, and the other one is sodas. I really don't want to use the letter S because it looks like the number 5, so I'm going to say P for pop. So we have 2 trips to the movies. The first time, 2 popcorns and 3 sodas for $25.50. I'm going to call popcorns C, and I should have called this pop. I'm going to call sodas P for pop. So I would not pick the letter S for sodas because it looks a lot like the number 5. So I know 2 popcorns, so 2C, plus 3 sodas, which I'm calling P, equals $25.50. The second trip to the movies is the next equation. So the next weekend they go again, 5 popcorns and 4 sodas. So 5 popcorns plus 4 pops equals $48. So once we have the equations written, this is very similar to the kind of problem that you guys just did. So we need to cancel out one of the variables. We don't have a coefficient, a 1 out in front of either one of these. So we can cancel out either variable. I'm going to cancel out the p's this time. So I know 3 and 4 both go into 12. So I'm going to multiply the top equation. I'm going to multiply this top equation by 4. So I'll get 8c plus 12p equals 102. Now the bottom equation, I want this value right here to be negative 12. So right now it's 4. That means I need to multiply this whole bottom equation by negative 3. And remember, you gotta multiply every single term. So negative 15c minus 12p equals negative 144. Now when we add these guys up, 8c plus negative 15c is negative 7c. I know the 12s cancel each other out. That was the whole point. And then on the right, we'll get negative 42. Divide both sides by -7, and we'll figure out a popcorn costs $6. That is what the question asked. Let's plug that back in just to make sure you guys know how to find how much the pop costs. I'm going to choose to plug that into the bottom equation, actually the top equation, whatever this one was, just because of the smaller numbers. So that's what it first looks like. 2 times 6, you get 12. Subtract 12 from each side. We'll get 3p equals 1350. Divide both sides by 3. And we know 1 popcorn equals $4.50. Now really the key part, I'm sorry, 1 pop. I already forgot what my variables were. The key part is that you guys can explain. So that tells me a pop is $4.50. And then the popcorn is $6. So ordered pairs are not as essential for the story problem ones. Make sure you can tell me what each item costs in this case. Alright guys, please work on the 5.4 homework. Work together, help each other out if you have questions. If you didn't get last night's homework done, the 5.2 story problems and 5.3, please work on that as well. Make good choices. See you later.